My name's Kevin Legrander.
John Misak.
Aydin Farajidavar.
Purushottam Meena.
Shaya Sheikh.
I'm Naomi Frangos.
James Siri. I'm an English professor. I teach writing, especially for the technical professions. I teach speech, and I teach literature. I especially focus on technology, culture, and literature.
Assistant professor of English, and I teach drama, technical writing, detective fiction, and composition.
This year, I'm working on a different project for virtual reality. John Misak and I are research partners in a project that we're trying to make an augmented reality phone app that is a game to help people understand Shakespeare.
This project is going to try and take a scene from Hamlet and turn it into an application for students' phones so they can explore, say, the castle of Hamlet or a particular scene in Hamlet so they can understand it better.
Shakespeare's plays are 500 years old and based in jolly old England, so a lot of students have trouble with that.
Another professor on campus, Dr. Legranger, was interested in the same thing, so we came together and we just wanted to find a way to make reading easier for students. We don't want to replace reading, we want to make it easier, and we feel this is one of the ways to do that.
We're trying to make an AR app that people can use to help understand and learn the humanities. We're starting with Shakespeare because Shakespeare is difficult for a lot of students, so that students can immerse themselves in the cultural and historical context. They might be able to understand the play better. I've spent 20 years doing technology and education, and virtual reality is the cutting edge of the cutting edge nowadays, and so I wanted to get involved in this project for that reason. But also, I think for students, both John Misak and I, my partner and I, think that this could, based on the research we've already done, could help students really understand Hamlet much better, and also have a lot of fun doing it. And we also get a chance to play with some really cool technology. Most of what I would consider my contributions to the academic community at large, and here at NYIT, probably would have to do with my research and writing about technology and ethics. John Misak and I would really like to express our gratitude to NYIT and all the people that have helped us here. Stan Silverman has been really great. Various faculty who are working with virtual reality in their fields, and it's surprising how many of us there are.
I'd like to thank my dean, Dean Quigley, Arts and Sciences, who has been very supportive of my work. Dr. Kevin Legranger, who is my partner in this project, who without him I wouldn't be able to do this. Our provost, Dr. Gonzalez, who's also been extremely supportive.
So I'm an associate professor of electrical and computer engineering. I'm also the associate chair for the department, and I'm also the director of our master program in bioengineering. I teach fundamental electrical engineering courses like digital logic, like electronics. I also teach fundamental courses in bioengineering, like medical devices. One of the most promising projects that we have been working on in the past few years is to develop an implantable device that can obtain the electrical activity from the stomach and deliver electrical stimulation to the stomach. Essentially, we are making a pacemaker for the stomach. So this is important for some of the functional gastric diseases like gastroparesis, functional dyspepsia. And people often ask me, how come you make devices, pacemaker for the stomach? They've never heard of it. But yes, stomach, like heart, has beats. And what we are trying to do in my lab to create an implantable device that can regulate the beats of the stomach. There are so many people who are suffering from a variety of gastric disorders. Specifically, when I saw patients with gastroparesis and the way that they are suffering from this disease, and they have very quality of life because all the time they are feeling nauseated and they have the feeling of vomiting, they have bloating. And worse than that, they cannot enjoy the pleasure of food in their life. So that's part of the reason I decided to work on this project. I would like to also thank my colleagues, my chair at College of Engineering, the dean at the College of Engineering. I would also like to thank the provost and the new president especially for providing the opportunity to sustain my lab.
I'm associate professor at the School of Management. I teach supply chain management, business analytics, operations management, statistics, and data mining.
Assistant professor, 4th year professor at School of Management. Like my colleague, I'm teaching operation management, supply chain management, and related courses to management science field.
We are working on 2 projects which are funded by NYIT together.
We have already received 2 internal grants, ISRC grants. One of them that we are recently focused on is about big data driven energy management in residential building. Since renewable energy are becoming more and more applied in day-to-day life, so what we are planning is that we are trying to rely on these renewable resources as much as we can and get rid of dependency to main grid for the city basically.
So what we are doing here is we are bringing 2 things, I would say 2 technologies together. One is machine learning based algorithm and another is big data analytics techniques together to solve this problem, which can provide optimal energy consumption ideas to residents.
At the end of the day, it reduces the utility costs for residents in the building and get rid of the pollutions that fossil fuels and non-renewable energy has, because now you're depend on the solar power or wind power and any other renewable energy. There is a problem here, and the problem is that all renewable resources are intermittent. Let's say during the day you have solar, during night you don't have it. So here what we do is that we add a battery in between, so that we have some energy stored during the night. We can use it during the night, and then during the day it will be recharged for the day later. My colleague can also provide more information about the same project that we are working on.
The overall idea of the project is to manage the energy consumption in residential buildings. So our main motivation was reducing the carbon emission and making business practices more sustainable.
We have been working on this project for about a year already, about a year and a half, and we have presented our initial progress in a top conference, international conference called POEMS. First of all, I want to thank my colleague for supporting me throughout this project. Special thanks to my colleague and my other colleagues in School of Management, and also those who are in charge of basically managing and holding this meeting during April. Special thanks to them. And that's basically the stage for us to show our contribution in research and in application areas.
I'd like to thank our ISRC grant that they funded this project, and we could use it for expanding our research, as well as we got the funding to present this work in the conference. And once again, thanks to the Shaya that we are progressing with this research pretty well.
I'm associate professor at the School of Architecture and Design at NYIT. Yes, I'm currently working on multiple projects. Recently, this academic year, I received an ISRC grant for my project entitled Bioinformed Structural Joint Design. It's a cross-disciplinary project that engages architecture, science, and materials, and uses algorithmic botany to inform the structural morphology. Basically, it's studying leaf venation patterns and branching patterns and trying to understand how an algorithm can be formed to dictate where the structural forms would go and where the joints would happen. I'm collaborating with a computational and structural engineer, and the initial stages of this project have been investigated with Dr. Alexander Vasilyev from the Osteopathic Medical School here at NYIT, using his lab to study microscopically the leaf patterns. So this work largely stems from my fascination with phenomena in nature's systems. And I first encountered this when I had an NSERC scholarship as a research assistant for a PhD student doing chemical studies of polymer growth under the microscope. Why this is so exciting to me as an architect is because we draw things that we build, and the processes involved often get hidden. So this exhibition would involve not only the final structure, but it would involve all this full-scale or in large-scale venation patterns from the leaf studies that would accompany the actual work, so that processes and product can be experienced together holistically as one way of designing. Well, I'd really like to thank the Provost for granting me this funding, as well as my Dean, Maria Perbolini, for offering me the opportunity to have course release and time to work on this grant, as well as many other collaborators in the school, and specifically Dr. Vasilyev for letting me use his lab and showing me how the microscope works, and my external collaborator, Dan Reynolds, who's doing some computational work with me to get this thing off the ground.
James Seary, I'm an assistant professor in the Department of Mechanical Engineering. I teach courses involving thermodynamics and fluid mechanics. So I had an ISRC grant last year called Improved Algorithm for Turbine Inlet Temperature Measurement. Through this project, we were able to demonstrate that we could get this to work. So we did testing on a rig. So we're not on an actual engine, but on a rig that they use to test some of the components for the engine. And we were able to show in there that we had good agreement. And then as we push this further, we've been able to show and get an idea of just what we can and what we can't tell by using this method. We're interested in gas turbines, which are gas turbines are like jet engines on airplanes, and they also use them for power generation on the ground. And those engines are really a modern marvel. And over the years, they've tried to make them more and more efficient so that they use less fuel. One of the key parameters for those engines to make them use less fuel is to raise the temperature that comes out of the burner inside the engine. So it's very high pressure, high temperature region, and they try to improve the engines by raising that temperature. And so it's important, as we've been improving these things, that you know how hot it's getting. So when engineers design the engines, they know from things like simulations how hot it should be getting, but of course you have to confirm that by doing measurements. I've also had a project that I've been working on since I've been here, where we're looking at droplets and the way that droplets interact with sound waves. I wouldn't have been able to do this project without the support of the ISRC program, because we've had an ISRC grant for it that I'm talking about now. And also our industry partner is Advanced Fuel Research, who was involved in actually collecting the data for the project. Also the sponsors at the Air Force, who originally came up with this idea and worked with us on getting it going.